Ini adalah gambar lab kami.
Okay, our presentation will be in English lah.
Macam nak kuat kan?
So try your best.
Apa dah tu?
The presentation must be in English.
Oh, must be. Alright. Okay. So this is our lab bending of a beam. Okay, I will tell about introduction and objective. So this experiment objective is the purpose of this investigation is to investigate the relationship between the load, span, and height of deflection in a beam, supported by two barriers and subject to the concentrate load. I will show the picture next. So this is the additional theory. A beam is a horizontal structure. It member in a structure that especially intend to bear lateral loads operating along the axis. It is essential component of the building construction efficiently resisting lateral or transverse stress. Unlike the stride or column, which are designed with the axial stress, the primary function of beam is to contract the load by bending reaction. Within the beam, this combined force produce shear force and bending moments, resulting in internal stress, strain, and deflection. Supported type is cross-sectional profile, equilibrium condition, length, and material composition distinguished. The picture shown is a beam and a column. So our experiment is about beam. The left one. Alright, next. Alright, there is two classification of beam according to the support condition and type of load. Okay, the first, according to the support condition, has 5: simply supported beam, continuous beam, fixed beam, and cantilever beam, and overhanging beam. For the classification of beam according to the type of load is like point of load, concentrate load, distributed load, and couple of force. This is the picture of beam types. Like I said before, the cantilever, simply supported beam, and overhanging like that. And for the type of load, the right one. So the C picture is contributed load, and first picture is axial load. Axial load.
Okay, proceed for next slide.
For next topic. Alright.
Okay, Assalamualaikum and good afternoon. Okay, so I will present the next topics. It's about the procedure. Okay, in our lab, we want to investigate the relationship between load and deflections. Okay, so first we set the barriers so that span about of 600 millimeters, and we place a test specimen with dimension of 6 times 25 millimeters on the barriers and amount of the load device in the center of the test specimen. And the third is we set the testing device so that the top of the gauge is centered on the upper plane of the load device. So that we set the gauge to 0 by press and hold the origin button. And then
Observation, because 4 minutes already.
observation.
Observation.
Because for procedure, I think we
We can skip.
Okay,
Alright.
we skip to the observation.
Alright.
Okay.
Rita.
Oh, result. Sorry. Okay, this is our result. Okay, for the relationship between the load and the deflections. Okay, the first load is about 5 newtons, and the deflection is about 0.27. The load for 10 newton is deflection 0.51, and 15 Newton, the deflection is 0.79 and load is 20.
What you can conclude based on this result?
The reading is more higher.
The based on this result, the load is more higher, and we're starting from 5 Newton to 20, but the deflection is also getting higher, getting bigger.
What
So,
is the unit of the deflection?
we use the Newton meter.
You should put in your slide.
Okay, yes.
Your next.
Okay,
Span length.
mm. Yeah, sorry. Okay, for the relationship for the span length is we can conclude that more increase the span length starting from the 300 to 600. We concluded that the deflection for the beam is also increasing from 0.07 to 0.51 millimeters. And then
What is the material of the specimen?
We use
we use the three different type of the specimen. Is first is a brass, aluminium, and steel. And then we go to
Because I thought there's only one.
Not-
Not one material.
eksperimen lain.
eksperimen lain. We use we use only one specimen. It's steel, but three different types of
Dimension.
thickness. Okay, I'm sorry, Dr.
It's okay.
Okay.
Yeah, you're quite nervous.
I'm quite nervous, Dr.
This is not job interview.
Okay.
Just one credit left.
Okay. Okay.
Next,
Next, the result.
The next result is the relationship between span and the deflections. In this experiment, we use three types of thickness, which is 4 mm times 25 mm length. The next one is 6 times 25 mm and 8 mm times 25 mm. Okay, we can conclude from this the smaller thickness of the specimens, we get the higher deflections. So when the thickness is higher, the deflection is smaller.
Why?
Why? Because the young modulus of specimen is changed due to the different thickness. Okay, I can show you the observations first. The load and the deflection in the beam bending experiment increase the load result in a proportional increase of deflections, showing a direct relationship within the evaluated load range. Okay, the second one is span length and the deflection experiments. The longer span length lead to the larger deflections, indicating a positive relationships between span length and the deflections. And the third experiments about test specimen height and the deflection, which is the test specimen height is the thickness of each specimen. We can say the taller specimen exhibits lower deflections, demonstrating an inverse connections between specimens.
Please change the taller specimen to be the length, the longest specimen,
Specimen.
or the longest span length.
Oh, okay. Uh,
So next. Okay.
invite bakery.
Next.
Next.
Or next.
Yeah. Wait, Azazah.
Oh, already finished.
No.
Sorry, yeah, I am interrupt your presentation is because of Q&A also. So I put Q&A together with your presentation.
Oh, okay.
Make it short. So anything enough?
Okay.
Observation, result discussion,
Uh,
and application.
we go through the
Application, no.
applications, or we need to explain about the calculation first.
No. You don't need to explain calculation because I already asked you about the result discussion only.
Oh, okay.
Okay. I think enough. Okay. We already have additional theory, observation, result and discussion, and also the application.
The discussions.
Okay. Discussion.
Okay. I pass this presentation to
I think
the.
the discussion I already asked you in the previous slide in the result discussion.
Oh,
Okay,
okay.
this one. This one. I'm asking you why the apa? The value, the deflection is decrease or increase. I'm asking you. Okay? And your answer is based on the Young modulus. Is it correct or not?
Yes.
So, okay, conclusion last lah.
Okay. I pass to Arif.
Arif.
Assalamualaikum and a very good afternoon to Doctor. So our conclusion, in conclusion, this experiment demonstrate the practical application of beam bending theory in laboratory context. We were able to discover the numerous elements that influence the extent of bending by carrying out this experiment. Furthermore, the percentage error found during the experiment is quite low, boosting the dependability of the produced data. Furthermore, this experiment provides useful insight regarding graph interpretation. Analyzing the experiment data allow us to obtain a better graph in the interpretation approach. It is vital to note that the deflection of the beam is controlled not just by the applied force or its position, but also by the beam size. So the major deflection varies significantly when the beam dimensions are swept, illustrating the importance of considering beam dimension in bending analysis. Overall, this experiment gives a true graph of bending beam theory and its accompanying component, emphasizing the use and the importance of laboratory-based research.
Okay. Arif.
Yeah.
My question first is what I don't know Arif or anybody lah.
Yeah.
Okay. My first question is what type of software did you use for your graph plotting?
Basically, I just using Microsoft Word to plot the graph.
Why?
Uh,
Last time I'm asking you to use professional software, right? Something like Origin Pro, something like the advanced one lah.
We already installed the application, Doctor, but we cannot access the the application.
Okay.
The app.
So how about the online base? online software? Have you tried?
Sorry.
Not yet lah.
Not yet.
Not yet.
Okay, so later on during your PSM, I wish that you try lah. Okay, this is the first question. The second question is about what do you understand about DOE, design of experiment?
Doctor, can you repeat the question?
Okay, the second question is regarding to DOE, design of experiment. What do you understand about DOE?
Design of experiment.
BIM gitu lah.
Design of experiments, which is the
experiment the
The variable, the setup, everything. The variable parameter, the design parameter setup, the variable of parameter.
Okay. What we, if I not mistake with your questions, what I understand about this design of experiments is, which is we use three difference of three difference of setup, right? Which is thickness versus deflections.
Yeah, correct.
Length versus deflections, and the last one is force versus deflections. Okay.
Okay. My question is, I already get your point. Okay, correct. This is correct. Okay, my question is, please suggest me if let's say, okay, this bending of beam is regards to your final year project. So can you propose to me any other parameter or variable that we wish to study, okay, regarding to bending of beam, besides of the span length, besides of the thickness, besides of the different type of load? What else?
The other variable can we use is the type of material of the beam.
Correct. Next. What else?
Maybe we can say that the setup of the beam.
Correct. What else? You have 5 members, so at least 5.
Material.
Okay, why I'm asking all of you is because
settle.
this is about your awareness. Okay, let's say during your PSM or final year project, you should think by your own about, maybe you have a supervisor to guide you, but of course your project, so you have a lot of you have to clear out lah your project. So you should think about the DOE lah, design of experiment. Okay, how to design your experimental setup, how to design about the parameter that you want to study, what parameter to be fixed, what parameter to be adjust or variable lah, something like that. So this is why I'm asking you lah, not just funny lah. Okay, I think enough. Okay, for Q&A question. So good luck for your future. Any question, any apa ni? Any opinion ke, cadangan ke about improving this class? Can you give 1 or 2 point?
Material.
Anything?
About this class or these experiments.
Anything.
Anything.
Okay, we already enough for oral test. Now you are free to give any point for me.
Material lah untuk kaji bending.
You tak boleh cakap tak ada sebab during your job interview, okay, let's say they asking you, okay, siapa Arif tadi, saya ingat Arif, Adib, Haikal. Okay, Haikal, Adib, do you have any question? So you kena ada tanya ataupun you kena ada pendapat. This is about what we practice during interviewing session.
Tak kisah. Full class. I think about buckling of struts. Right.
The tool is to
all not up to date lah. Buckling of struts because we had difficulties to
open and
adjust
the
zeros.
Yes.
To adjust to the zero. What? Zero
point.
Reading.
Zero reading.
Oh, you want to apa ni? Set up the apa tu?
The new setup. I think we can use the new setup. If UTSM provide up to date what we call up to date setup, maybe we can save the time out.
The apa? Equipment ke the
Equipment, yes. Maybe we can save more times to reset the force to back to zero lah.
Buckling of strut.
Yes.
Okay. I take note. Buckling of strut. The second experiment, buckling of strut.
Yes.
Okay. Anything? Any else? Yes.
For the beam, for the bending of beam, we can use different materials to make experiment. So we can know the bending for other material.
Oh, okay. You mean to apa ni? Additional sample?
Yeah, additional sample.
Okay.
So far, no, doctor, from us.
So far so good. Okay. If enough, then okay, can dismiss. Thank you very much. And good luck for your future. BSM already done or not?
No.
BSM 1 next semester.
Yes, next semester.
How about internship?
No.
Not thinking yet.
This next July?
I think so.
Your internship.
Yes.
Have you registered yet?
The doctor, I have confused about this. There is taklimat